Alright, we are working some calculus. We're in the section of limits and we're looking at continuity and one-sided limits. And this is the button we're working on there. So let's take a look at what we got. We got a piecewise function now. This is this is not how it's written, but I'll write it on the board here in a minute. How you'd normally see it. We got the limit as x approaches 6 from the right hand side of f of x. Let's bring up the whiteboard. And of course, let's clear that off. Okay, we have the function f of x, a piecewise function, and of course this is traditionally how it's written, big curly bracket there. We have x, and then the domain of this x, this part of the function, is greater than 6, and then we have x plus 1, and its domain is less than or equal to 6, and we're asked to find the limit as x approaches 6 from the right hand side. Now, since we're coming in, we'll use that color there for xy axis. Okay, since we're coming in at 6 from the right hand side, we're going to be using this part of the function up here. Okay, it says all x values greater than 6. Alright, all x values greater than 6. Now I'm going to kind of sketch out what this function looks like. There's a 6 there, so we have an open circle because we don't include 6. Okay, and of course a slope of 1, so we'll say it's something like that, going off in that direction. And then we have an x plus 1, and so that's going to be at 7, plugging 6 into plugging 6 into here. 6 plus 1 is 7, and then it's a closed circle, and of course it's got a slope of 1. These should both be parallel lines, and it doesn't look like something's to scale here, but anyway, so this is what we're looking at, and we're trying to find the limit of this guy here. Now of course we're going to be using this top one up here. Okay, now there's a theorem that's stated that if this is true, or coming in from left, coming in from the right, now of course there is no left to this problem. If we're coming in from the left hand side, it's going to be 7, but coming in from the right hand side, it's going to be 6. So as you can see here, this limit does not exist. Okay, this limit does not exist. But we're coming in from the right hand side. Now you can plug some numbers in that's real close to 6, like 6.001, and see where this missing point right here, what it's actually converging to. Alright, and of course it's converging to 6. Okay, as we can see there. Now one other thing, since we're in the section of continuity, we can see that this function is not continuous at 6, and it's not continuous at 6. Three things have to be met, and first off, this particular one right here does exist, and it's actually 7, right? We plug 6 in, we get 7 out up here. Okay, but the limit, now remember that the limit must exist as x approaches 6, and this limit does not exist, and that's where it actually fails. However, this function is continuous everywhere else on the real number line except at 6. Alright,